Electricity has always fascinated humanity. The ancient Greeks were the first to document it. They noticed that amber, when rubbed, could attract small objects. They called it electron, which means amber in Greek. This is where we get the word electricity from. For centuries, electricity remained a mystery. People observed it in lightning strikes and static shocks. In the 17th century, things began to change. Scientists started to study electricity more closely. They built simple machines to generate static electricity. The real breakthrough came in the 18th century. This was the Age of Enlightenment. It was a time of great scientific curiosity. Electricity was one of the big mysteries they tackled. During this time, many scientists contributed to our understanding of electricity. They built on each other's work. But one name stands out in this story. That name is Benjamin Franklin. He was about to make a discovery that would change the world. Benjamin Franklin was a man of many talents. He was a writer, a diplomat, and an inventor. But above all, he was curious. He wanted to understand how things worked. This curiosity led him to study electricity. Franklin lived in a time of great change. The American colonies were growing. New ideas were spreading. Franklin was part of this intellectual revolution. He even conducted his own experiments. Franklin was particularly interested in the nature of lightning. This practical mindset led to one of his most famous inventions, the lightning rod. The year was 1752. Franklin had a theory about electricity. He believed lightning was a form of electricity. But how could he prove it? He devised the Kite Experiment. Franklin attached a metal key to a silk kite. He tied a silk ribbon to insulate himself. On a stormy day, he flew the kite. A spark jumped from the key to his knuckle. Lightning was indeed a form of electricity. Franklin's kite experiment was groundbreaking, but it was also incredibly dangerous. He was essentially trying to attract a lightning strike. One wrong move could have been fatal. In fact, other scientists who tried to replicate his experiment weren't so lucky. Some were seriously injured. Others lost their lives. The dangers weren't just from the lightning itself. The electrical charge in the air was also a risk. Even without a direct strike, the buildup of charge could be deadly. Franklin was aware of these risks. That's why he used the silk ribbon as an insulator. But it was still a huge gamble. Despite the risks, Franklin persisted. He believed that understanding electricity was crucial. He saw its potential to improve people's lives. This drive for knowledge outweighed his fear of danger. Franklin's bravery paved the way for safer methods of studying electricity. Franklin's kite experiment was just the beginning. It opened up a whole new field of study. Scientists now had proof that lightning was electrical. This led to a better understanding of electricity as a whole. Franklin developed a theory of positive and negative charges. He introduced terms like battery, conductor, and electrician. These contributions went beyond just naming things. They provided a framework for understanding electricity. Franklin's work helped other scientists make new discoveries. It paved the way for future inventions. The electric motor, the telegraph, and even modern computers all owe something to Franklin's pioneering work. But Franklin wasn't just a theorist. He was also an inventor. His most famous invention was the lightning rod. This simple device could protect buildings from lightning strikes. It was a practical application of his electrical theories. Lightning rods saved countless lives and prevented massive property damage. They're still used today. Franklin helped usher in an age where science, not superstition, explained the world. Franklin's discoveries laid the groundwork for the electrical revolution. In the centuries that followed, electricity transformed the world. It powered the Industrial Revolution. It lit up our cities. It enabled global communication. All of this can be traced back to Franklin's curiosity about lightning. Today, we take electricity for granted. We flip a switch and lights come on. We plug in our devices and they work. But every time we do this, we're benefiting from Franklin's legacy. His work is still relevant today. Modern lightning protection systems still use principles he discovered. His experiments with charge distribution inform how we design electrical grids. But Franklin's impact goes beyond just electricity. He exemplified the scientific method. He showed the importance of observation, hypothesis, and experimentation. He demonstrated how scientific discovery could lead to practical inventions. This approach to science and innovation continues to drive progress today. As we look to the future, Franklin's spirit of inquiry remains relevant. we're still building on Franklin's legacy. Stay tuned for the next chapter on Alessandro Volta and the invention of the battery. Alessandro Volta, born in 1745 in Como, Italy, created the first true electric battery in 1800. His Voltaic Pile produced a steady flow of electric current, revolutionizing electrical storage. Volta's work paved the way for modern technology and scientific research. The unit of electric potential, the volt, is named in his honor.